Alright, today we will finish off section 1.4, which is on surface area and volume of prisms, but today what we're going to do is the dreaded surface area. So what is surface area? Surface area is the total area of all the faces that enclose a three-dimensional solid. Again, it has to be three-dimensional. The units for surface area are square units. Millimeters squared, centimeters squared, meters squared, etc. So the difference between volume and surface area. Volume, remember, is how much space is inside of a three-dimensional object. It's kind of like if you took paint and you filled up this cube with paint. How much paint could you could you put inside this cube? That's what volume is. What surface area is the amount of area on the outside. If you took the paint and you painted the outside of this cube, how much paint would you take up? So that's the way I try to separate them in my mind if I forget. Think of paint. Volume, you're filling it up with paint. Surface area, you're painting the outside. Okay? There's no one formula I can give you for surface area. Basically, the formula is find the area of all the faces. So let's do some examples, and you'll see that's always the strategy, is to take a look at how many faces there are any of the faces the same as each other, and get the area of all the faces. So for example, the first shape here is a cube, or as we learned last time, it's also called a square prism. Okay, I've tried to draw in the edges at the back, the hidden edges. I don't think I did a very good job. But anyway, what we need to do is we need to get the area of all the faces that make up this cube. So how many faces does this have? Well, it has front and back, left and right, top and bottom. It has 6 faces. Let's just look at one of the faces. How about this one right here? Whoops. Okay, so what we want to do is we want to get the area of that face. Well, that's a square. What's the formula for the area of a square? Length times width. So length and width in a square, and this square up here is 3 by 3. So the area is 9. Now, how many faces are there that are that size? They're all that size in a cube. So what are we going to do with the 9? We're going to multiply it by 6, because this face has the same area, this has the same area, all 6 of them have the same area. So we multiply by 6 because all 6 faces have the same area. And we end up with our answer. 9 times 6 is 54. Remember this dot dot here, this not dot dot, this dash dash here means inches, so this is 54 inches squared this time. Okay, next one. This is a rectangular prism. Again, it has 6 faces. Let's take a look at one face. How about the top face up here? So the area of the top, well, it looks like a square. It's actually a rectangle, so it's length times width. What's the length and the width of that? Well, it's definitely 4 this way. How much this way? It's going to be the same as this, 7. So it's 4 times 7 equals 28. That's for the top. Is there any others of that size? Yeah, the bottom's exactly the same. So we need to multiply by 2 because the bottom is the same. Bottom is the same. Don't worry, I'm not going to make you write this. Bottom is the same. All faces are the same. I just want you to understand why I'm multiplying by 2. So that's 56. Okay, we've done the top and the bottom. How about the front and the back? So front. So for front, I'm talking about this one here. That's a rectangle, so it's length times width. What are the dimensions? Well, it's 7 this way and 10 that way. So 7 times 10 is 70. How many of those are there? 2, because the back is also the same. This one over here is not the same. I know they're both rectangles that are kind of tall, but it's not the same dimension, so don't multiply by 4. There's only 2 of them in this case, front and back. So you have to multiply by 2 is 140. Okay, we've done top and bottom, front and back. How about the sides? So for the sides, I'm talking about ones like, what's going on here? I'm talking about ones like this one. What are the dimensions of that one? Well, this dimension here is the same as this here, which is the same as this here, so it's 4. And this dimension here is the big long dimension. It's the same as this one, same as this one. It's 10. 4 times 10 is 40. How many of those are there? Well, there's another one of those on the other side, the left side, as well as the right side, the same. So you get this. What do you do with these 3 answers? You add them up. 140 and 80 is 220 plus 56 is 276 centimeters squared. Okay, next, triangular prism. How many faces does a triangular prism have? Not 6, 5. Let's call them front, back, bottom, and then the two triangular sides. Let's start with the area of the triangle, or triangles. Remember what the formula is for the area of a triangle? Base times height divided by 2. Base and height are always at a right angle. They always meet at a right angle. So if we look at this triangle out here, you can see that there's the right angle. The base is 10, the height is 15. So 10 times 15 divided by 2, which equals 150 divided by 2, which is 75. Now, how many of those are there? There's two triangles that size, so we have to multiply by 2. You end up with 150. I know, some of you are yelling, why would you bother doing that? Why would you divide by 2 and then multiply by 2 after? You could just do 10 times 15. I know, and if you understand that, good for you. I just don't want people to get confused and think, oh, when you get the area of a triangle, you don't have to divide by 2. You do, okay? So if you understand about canceling those two out, great. If you don't, just do exactly what I did. Get the area of the triangle by going base times height divided by 2, and then multiply by 2 because there's two triangles. Okay, the area of the bottom. So the bottom, I'm talking about this piece here down there, right? So that's a rectangle, so it's going to be length times width. And what are the dimensions of that? 20 this way, 10 that way. So 20 times 10 is 200. How many of those are there? If you said 3, you're wrong. There's only one of those, okay? Just because this is a rectangle and this is also a rectangle does not make them the same. So there's only one. Don't multiply it by 2 or 3 or anything. Okay, now the area of the front, which I think we have to assume. It doesn't show us. It should show a little, it should show that this is an isosceles triangle by doing this. Have you seen that before? That means that this is the same as this length. But I think we're just going to have to assume it here that they're the same. So this rectangle at the front is the same as this rectangle in the back. So we're going to have to multiply by 2 once we figure it out. Okay, it's a rectangle, so it's length times width. What are the dimensions of this rectangle? Well, we know that this dimension here is 20. So it's going to be 20 times. And this dimension here is the other part of that rectangle. How big's that? I don't know. It doesn't give us that answer. Uh-oh. What do we do now? Well, now what you have to do is a little fancy move here. So I'm going to draw this triangle right here. See that? That triangle, I've just redrawn it there, not very well. If this is a right angle here, then it's also a right angle on the other side. So it's a right angle. The height of this triangle is 15. How much is this here? It's not 10, that's the whole way across. So this is only halfway across because it's an isosceles triangle. So it's only 5. And we want to know this amount right here. I'm going to call it C, hint, hint. How am I going to figure out what that side is? You're going to use the good old Pythagorean Theorem. A squared plus b squared equals c squared. So you want to know the biggest side, the hypotenuse, so you're going to square these ones and add them. So it's going to be 15 squared plus, because you want a bigger number for the hypotenuse, 5 squared equals c squared. 15 squared is 225. 5 squared is 25 equals c squared. 250 equals c squared. So that means c, take the square root of both sides, right? C is equal to the square root of 250. And if you get the square root of 250, it's 15.8 approximately. It's very close to the answer. Okay, so what you have to do for this rectangle is you have to go 20 times this distance right here, which we just found out was 15.8, this distance right there. So 20 times 15.8, which equals 316. Now, how many of those are there? 2. So you have to multiply that by 2. You get 632. So you have this amount, you have this amount, you have this amount. What should you do with those? Add them up. You get 832, 932, 982 centimeters squared. Over the page we go to our trapezoidal prism. We need to get the surface area of this. How many faces does this have? Quite a few. It has the trapezoids, 1, 2, and then it has 1, 2, 3, 4 rectangles. So there's 6 faces here. Let's get the trapezoids first. Area of trapezoids. If you remember from last class, The way you get the area of a trapezoid is a plus b, which are the two parallel sides, times the height divided by 2. So a plus b, we did this before, right? It's 2 this parallel side and 5 this parallel side, so 2 plus 5, times the height of the trapezoid, which is 3, and then we're going to divide that by 2. So you get 7 times 3 is 21, divided by 2 is 10.5. How many trapezoids are there? 2. So you get a total of 21. I know, again, this is another one. Why did you divide by 2 and then multiply by 2? They just cancel. I know. I'm just doing this to be crystal clear what's going on. Okay, let's get the area of the sides. And when I talk about sides, I mean, you can call it whatever you want. I'm calling this the sides here. And I'm going to call this the front and the back. Anyway, that's what I'm calling the side. That's a rectangle, so it's length times width. What is the length and width? 6 and 3.5. That equals 21. How many of those are there? Careful, there's only one more. Again, I think we're supposed to assume that this is an isosceles trapezoid, that this is the same as this. So that means that this one over here, which you can't really see all that well, that's the same as the one I've outlined here. So there's two of them. 21 times 2 is 42. Okay, let me erase this. And the next one I want to do is the front. So when I say the front, I mean talking about this. Again, maybe that's what you're calling the left. I don't care. As long as you get them all, it's fine. That's a rectangle, length times width. What are we multiplying there? We got the dimension 5, and how much is this? Well, it's the same as this, which is the same as this, so it's 6. 5 times 6 is 30. How many of those do we have? Just one. We still have the area of the back, which is a smaller rectangle, so it's again length times width. And if you can't picture it, I'm talking about this partially hidden guy back there. Well, it's 6 up and 2 across. So it's 2 times 6, which is 12. Take your 4 answers, 1, 2, 3, 4, add them up. 72, 84, 104, 105 centimeters squared. That's a 0, not a 6. Last one, the composite shape. There's different ways you could do this. So one way that sometimes people do this is they find the surface area of this little piece here, the little block, all of it, even the bottom. Then they get the surface area of the bottom block, even the top, and then they subtract the overlap. That works. I'm not going to do it that way. It's just a little bit of extra work. There's a couple other ways to do it. I'll do it 2 other ways, and you can decide which way you like. So let's call this top little block here A, and the big one down here, let's call it B. And one way you could do it is you could just go through and look at every face that's exposed, because remember, when you're talking about surface area, you're talking about like the outside faces. If you have one block sitting on another, you've just lost some surface area, right? You could not paint. You're only talking about surface area, you're only talking about the stuff you could paint. And you could not paint underneath this little block anymore because it's covered. So the overlap is definitely what makes the surface area of composite shapes quite difficult at times. So let's take a look at A. For the top of A, so we're going to get the area of the top of A. It's a bit confusing, but really what I'm talking about is this up here. So that is, these are all rectangles, so it's always going to be length times width. I'm not going to put L times W every time. Length times width. So 4 times, how much is that? 5. So 4 times 5 is 20. Do I multiply by 2 because of the bottom? No, because that's covered, so we don't have to worry about that. Okay, the area of the right of A. The right of A I'm talking about over here. That is also 4 times 5, which is 20. Do I multiply that by 2? Yes, because the right and the left are the same. Okay, so I've done top and bottom, but I didn't have to include the bottom. I've done right and left. What do I still need to do? I still have to do the front of A. The front of A, I'm talking about this. How much is that? That's 4 times 4, which is 16. How many of those are there? 2, because there's also the back, so 32. Okay, we've done all of A. Let's move on to B. For B, we have to do the, I don't know, let's do the front of B first. Front of B. So that's this area here. How much is that? That's 8 times 4, which is 32. How many of those are there? 2, because there's also the back. Okay, let's do the side of B. That's over here. How much is that? 5 times 4. How many of those are there? 2, because you can also do the left. So that's 40. Now let's do the bottom. So the bottom is this, all this down here, right? So that's 8 times 5, which is 40. How many of those are there? Just one, because the top isn't exactly the same. It's partially overlapped. It's partially covered. So you can't just multiply by 2. And the area of the top, oh, this is a B and this is a B. The top of B. So if I'm talking about the top of B, all I'm talking about is this bit right here. How much is that? Well, we know that this right here is 5. So what we have to figure out is how much is this? Okay, well, this whole amount is 8. This here is 4. So how much must this be if it's all got to equal 8? This must be 4 as well. So this is 4 times 5. 4 times 5, which is 20. Add all these up and you'll get your answer. 20, 60, 80, 120, 160, 224, 226, 256. So your final answer is 256 meters squared. Okay, I want to show you a different way. It's almost the same, it just saves a little bit of time. Let me erase all this and show you how you could maybe do this a little bit quicker. Let's start by looking at the entire composite shape. And the first thing I want to do is I want to get the area of the bottom of the entire thing. So the area of the bottom, well, that's this bit right here. It's a rectangle, length times width, so it's 8 times 5, which is 40. Now, if you look at the top of the whole thing, do you see that if you combine this with this, it's exactly the same size and shape as the bottom? If you were to look straight down, like a bird looking straight down, do you see that it would look exactly the same as this rectangle here? It would look exactly the same, but there would be a line in the middle, but you wouldn't be able to tell what's higher or lower. But the area would be exactly the same. If that makes sense, this could be a method for you, because all you have to do is take the bottom and multiply by 2. So you got 80. Now let's do the area of the left hand side of the whole thing. So we are looking at this whole, big rectangle here. What are the dimensions? Well, across here is the same as here, it's the same as here, it's the same as here. It's 5. And this amount is 4 plus another 4, so this whole amount here is 8. In other words, what we have is length times width again, 5 times 8, which is 40. And if you look at the right side, you see again that this amount here and this amount here, if you were looking from the right hand side, it's exactly what this would look like to you is exactly this green rectangle over here. It's exactly the same size and shape. So again, it'd be times 2, you'd have 80. Okay, what do we still need to do? We still need to do front and back. Now for front and back, you can't, this is like an L shape. We don't have any single formula for the L shape, so you're going to have to do the same thing we did before. The area of the bottom, so I'm just doing this now, the front, that is 8 times 4, which is 32, and there's 2 of those because there's also the back, and then the area of the top, these are both front, right? Front. The area of the top is 4 times 4, 4 times 4, and you multiply that one by 2 as well because there's the back. You get 32. 0, 0, 4, 2, 6, 16, 20, 22, 256 meters squared. What do you know? It's exactly the same as we got over here, so I feel pretty good about that. So you can do it a little bit quicker if you can get this idea of 2 faces combining to make the same as another face. Okay, that's surface area. Good luck with it. You got to go slow with it. Do lots of writing. Don't try to do it all in your head. You will get it wrong. You want to write stuff down, be methodical, and you'll get the right answers.